Assalamu alaikum warahmatullah. Today we'll start lesson 6, unit number 5. This lesson is the relation between the tangents of the circle. First, the relation here is theorem. The theorem is the two tangent segments drawn to the circle from point outside it are equal in length. Look at the figure. Here I have AB and AC are two tangents of circle M. From point A, this point is outside the circle. Therefore, the length of AB equals the length of AC. That means the two tangents are equal in length. The second relation is corollary number 1. Let's see. The straight line passing through the center of the circle and the intersection point of the two tangents is an ax of symmetry to the chord of tangency of those two tangents. Again, look at the figure. AB and AC are two tangents from point A outside the circle. Then the straight line which passing through the center of the circle and this point A is ax of symmetry of the chord which join between the two points of tangency. Okay, now what the meaning of straight line ax of symmetry of CB? That means D is a midpoint of the chord BC and also AM straight line perpendicular to a chord BC. So, since line segment AB and AC are two tangents to the circle M, and straight line AM joins between point A and the center M, therefore, straight line AM is ax of symmetry of chord BC. That means CD equals BD, and also AM straight line perpendicular to CB. Relation number 3. Relation number 3 is corollary number 2. The straight line passing through the center of the circle and the intersection point of the two tangents bisects the angle between those two tangents and also bisects the angle between the two radii passing through the two points of tangency. Again, now here I have two tangents AB and AC from point A outside the circle. Then this straight line AM, which is passing through the center and point A, this straight line bisects two angles, angle A and angle M. This angle, measure angle CAM, equals measure angle BAM, and also measure angle CMA equals measure angle BMA. Let's see. Since AB and AC are two tangents to the circle M, since AM straight line join between point A and the center of circle M, therefore measure angle CAM equals measure angle BAM, and also measure angle CMA equals measure angle BMA. Let's summarize what we have studied in the three relations. Now, if I have two tangents of a circle from point outside the circle, then AB equals AC. The length of the two tangents are equal in length. Okay. And This straight line which passing through the center and point A bisect angle A and bisect angle CMB. Again, this straight line bisect angle CAB and also bisect angle CMB. And this straight line MA is axis of symmetry of chord BC. What the meaning of axis of symmetry? That means this straight line bisects the chord and also perpendicular to this chord. Now drill number 1. In each of the following figure, line segment AB and line segment AC are two tangent segments in circle M. Find the value of symbol used in measuring. Now figure number 1. Here I want to find the value of X and the value of Y and Z. Look at the figure. Here I have two tangents AB and AC from point outside the circle. Yes, that means AB equals AC. So the triangle ABC is an isosceles triangle. Now I can find the value of X. Value of X equals 180 minus 50 divided by 2. So X equals 65. What about angle Y? Angle Y here is part of angle ACM, but measure angle ACM equals 90. Why? Because AC is a tangent and MC is radius of the circle. Therefore, this radius perpendicular to the tangent of the circle from point of tangency. Then Y equals 90 minus 65. Then Y equals 25. Now I can find the value of Z because triangle CMB is an isosceles triangle because the two sides of this triangle are two radii of the circle. Now measure angle Z equals 180 minus 2y. So X equals 65. Y equals 90 minus 65 equals 25, and Z equals 180 minus 50 equals 130. Now number 2. Look at the figure of number 2, and also I want to find the value of X, Y, and Z. Now, two tangents from point A outside the circle, therefore AB equals AC, and also the straight line AM bisects angle CAB and also bisect angle CMB. Okay, now measure angle X equals 35. Okay, because AM bisect angle A, then X equals 35. What about Y and Z? As we can see here, value of Y equals value of Z because AM bisects also measure angle CMB. So if I find value of Y, then I have value of Z. How to find value of Y? From the triangle ACM. Here, triangle ACM is right angle triangle at C. Why? Because MC is a radius and the AC is a tangent. Then measure angle C equals 90. So Y equals 180 minus 90 plus 35. Then Y equals 55 degrees and also Z equals 55 degrees. This is X, 35, Y equals 55, and also Z equals 55 degrees. Now, problem number 3. Look at this problem carefully. The given here, the length of AC equals the length of CB. And also, AB and AC are two tangents from point A outside the circle. That means AC equals AB. Now I have triangle ABC is an equilateral triangle. Okay, the three sides are equal. That means each angle of this triangle equals 60. Now y equals 60. What about x? I know that AM bisect angle A and the measure angle A equals 60. Then x equals 30 degrees. Now I have 60. Now I have a value of x and the value of y. What about z, the measure of angle D? Now, angle CDB is inscribed angle subtended by arc BC. Okay, and also measure angle CMB is central angle subtended by the same arc BC. That means uh, measure angle Z equals half measure angle CMB. But I don't know the measure of angle CMB. How to find the measure of angle CMB? I said before x equal uh, 30. So angle CAM equals 30 also. And measure angle ACM equals 90 degrees. Why? Because MC is radius and AC tangent. Okay, so this angle equals 90. 30 and 90, then the third angle of the triangle ACM equals 60. Again, ACM, sorry, AMC, this angle AMC equals 60 degrees. Now, measure angle AMC equals measure angle AMB because AM bisect angle CMB. Now, the angle, measure angle CMB equals 60 plus 60 equals 120. Then Z equals half 120 equals 60 degrees. X equals 30 degrees, Y equals 60 degrees, and also Z equals 60 degrees. Now, definition. The inscribed circle of polygon is the circle which touches all the sides internally. Again, inscribed circle touch the all sides of any polygon internally. Touch the all sides. In opposite figure, M is inscribed circle of triangle ABC because it touch all sides internally at point D, point E, and point F. That means the triangle ABC is drawn outside the circle M. So, inscribed circle means this circle touches the all sides of the polygon, and this polygon drawn outside this circle. Now, drill number 2. Find the value of the symbol used in measuring. Now I have 3 problems. Problem number 1, problem number 2, and problem number 3. I will solve problem number 2 and 3. Then I will ask you to solve number 1 yourself. Now, problem number 2. Here I have 2 circles touching externally. And I have point A outside the 2 circles. AB and AC are 2 tangents of the greater circle, and AC, AD are 2 tangent of the smaller one. Now I can find the value of x and value of y. How? The two tangents AB and AC are equal in length. Then 2x minus 3 equals 15. So I can find the value of x here. And also the length of a tangent or AC equals 15. And also tangent AD equals tangent AC. So AD equals 15. Then y minus 2 equals 15. Therefore y equals 17. Now look at the answer. 2x minus 3 equals 15. Therefore 2x equals 18. Then x equals 9. What about y? Y minus 2 equals 15. So y equals 17 centimeter. Now look at number 3. Here I have circle inscribed the triangle. Inscribed circle means this circle touch the three sides of the triangle at 3 points. Okay, D, F, and E. This point is E. Okay. Now, when we look to the figure, we find 3 points, the three vertices of the triangle, the 3 points outside the circle. Then from point A, I have two tangents of the circle, but BE equals x. Therefore, BD equals x also. Okay. What about the two tangents from point C? Now CF equals CE. So CE equals Y and CF equals Y also. Let's denote it by Z to represent the length of tangent AD. Then AD equals Z and also AF equals Z. So the parameter here consists of 2x plus 2y plus 2z. The parameter here equals 6 plus 7 plus 5 equals 18. Now 2x plus 2y plus 2z equals 18. Then when we take 2 common factor, therefore 2 open bracket x plus y plus z equals 18. Then x plus y plus z equals 9. Okay, but BE plus EC equals 7. X plus y equals 7. And x plus y plus z equals 9. Therefore, z equals 2. Now, this part AD equals 2. Then x equals 4. X equals 4. What about y here? 7 minus x. 7 minus 4 equals 3. Now, the answers. X equals 4 and y equals 3. Now, solve number 1 yourself. Stop the video and solve number 1 yourself. Then check your answer. These are the answers of number 1. X equals 12 centimeter and y equals 8 centimeter. Now, exercise number 1. In the opposite figure, AB and AC are two tangent segments to the circle M. AB parallel to CD, measure angle BMD equals 130. Prove that ray CB bisects angle ACD. What the meaning of ray bisects angle ACD? That means I want to prove that measure angle DCB equals measure angle BCA. This angle equals this angle. Then CB ray bisect angle ACD. And also I want to find the value of angle A. Now let's start. At the beginning I have angle DCB is inscribed angle subtended by arc BD, and also angle BMD, central angle subtended by the same arc. Then measure angle BCD equals 130 divided by 2. Now I have the measure of angle BCD. If I can find the value of angle ACB and also equals 65 degrees, then CB is CB bisects angle ACD. How to find the value of this angle? Now, point A outside the circle M, therefore AB and AC are two tangents of circle M. That means AB equals AC. Okay? Now, measure angle ABC equals measure angle ACB. What about the value of angle CBA? Angle CBA, measure angle CBA equals 65. How? From parallelism. Here I have CD parallel to BA, DC parallel to BA, and CB is a transversal. Therefore, measure angle CBA equals 65 degrees, alternate angles. And also, measure angle ABC equals measure angle ACB. So, measure angle ACB equals 65. Now, CB ray is bisect angle ACD because each of the two angles equals 65 degrees. Now, what about the measure of angle A? It's very easy. This triangle ABC, I have two base angles, each of them equals 65. So the value of angle A equals 50 degrees. Let's see our steps. In circle M, since angle DMB is a central angle and the angle DCB is inscribed angle subtended by the same arc BD, therefore measure angle DMB is twice measure angle DCB. Therefore, measure angle BCD equals 65. Since DC line segment parallel to line segment AB and CB is a transversal, therefore measure angle DCB equals measure angle CBA equals 65, alternate angles. Since AB and AC are two tangents to the circle M, therefore AB equals AC. That means measure angle CBA equal measure angle BCA. This is number 2. From 1 and 2, therefore measure angle DCB equal measure angle BCA. Therefore ray CB bisects angle ACD. This is the first required. The second required, find the value of angle A. It's very easy. From the triangle ABC, therefore measure angle A equals 180 minus 65 plus 65. Then 180 minus 130 equals 50 degrees. Exercise number 2. In the opposite figure, straight line AB is common tangent of the two circles M and N externally at point A and B respectively. Their two radii lengths are 17 and 8. If MN equals 41 centimeter, find the length of AB. I want to find the length of AB. This line segment AB. Okay, how to find the length of AB? Here I need two constructions. Okay, now firstly I will draw constructions. What are the constructions here? I will draw the radius of circle M and also the radius of circle N. And I will draw perpendicular from point N to the radius of the greatest circle to intersect at point C. Okay? Then the constructions here, draw two radii of the two circles M and N and NC perpendicular to MA. Now I have two radii and common tangent. Therefore, the two radii perpendicular to the tangent AB. Now I have measure angle A 90 and the measure angle AB 90 also. And NC perpendicular to the radius MA. Now measure angle C equals 90 degrees also. So the figure ACMB is a rectangle. Now how to find the length of AB? Now stop the video, solve this problem yourself, then check your answer from the model answer. Okay, now the steps. The last problem. In the opposite figure, M and N are two circles touching externally at point D. The straight line AB is a common tangent to the two circles M and N at A and B. DC ray is common tangent to the two circles at point D, where DC ray intersect straight line AB at point C. Prove that. Firstly, C is midpoint of AB. I want to prove that C midpoint of AB. That means I want to prove that AC equals BC. This is the first required. The second required, I want to prove that line segment AD, this line segment, perpendicular to line segment BD. So I need to prove that measure angle ADB equals 90 degrees. Let's start with first required. I want to prove that point C is midpoint of AB. So I need to prove that AC equals BC. How? Look at point C. Point C is outside circle M. Then the length of CA equals the length of CD. Why? Because the two lines AC and CD are two tangent of circle M. Then AC equals CD. And also in circle N, by the same method, I can find CD equals CB. Now, AC equals CD and CD equals CB. Therefore, AC equals BC. That means C is a midpoint. This is the first required. The second required, how to find the measure or how to prove that this angle ADB equals 90 degrees. Now, here I have two chords, one of them chord of circle M and the other one chord of circle N. Look at the triangle ACB. I said before the length of AC equals the length of CD. That means the measure of angle A equals the measure of angle D. CDA. Okay? And also in the second triangle, CDB, CD equals CB. That means measure angle B equals measure angle CDB. Then this angle equals this angle. And also this angle equals this angle. Now, if I add the two equations, then measure angle B plus measure angle A plus measure angle B equals measure angle CDA plus measure angle CDB. Two angles equals two angles, and the sum of interior angles of the triangle ABD equals 180. That means measure angle ADB equals 180 divided by 2. Therefore, ADB equals 90. That means AD perpendicular to BD. Let's see our steps. The steps here in circle M. AC straight line and the DC ray are two tangents of circle M from point C. Therefore, AC equals DC. This is number 1. In circle N, the same. Two tangents, then BC equals GC. This is number 2. From 1 and 2, therefore, AC equals AB. That means C is a midpoint of AB. This is the first required. The second required, from equation number 1, AC equals DC. Therefore, measure angle CAD equal measure angle CGA. This is number 3. And from 2, BC equals DC. Therefore, measure angle CBD equals measure angle BDC. This is number 4. By adding 3 and 4, therefore, measure angle CAD plus measure angle CBD equals measure angle CDA plus measure angle BDC. That means measure angle ADB equals 90 equals 180 divided by 2 equals 90. Therefore, AD perpendicular to DB. Now, thank you for watching. See you later in a new lesson of geometry. Thank you and goodbye.